Hello class, I'm working out of your Algebra 1 book 6.1 graphing lines. To get started, if you're asked to write a linear function such as f of x equals negative 5/7 x plus 2 as a linear equation in standard form, your standard form is ax plus by equals c, and you want to mimic that format. So we will work from f of x now becomes a y because they're somewhat interchangeable in terms. And we'll set out our negative 5/7 x plus 2. We're going to add 5x to the 5/7 x to both sides algebraically to move the x term to the side, as in this format. We have a y term and an x term on that side of the standard form equation. So if we add 5/7 x to both sides, we now have 5/7 x plus y equals 2. We want to get rid of the denominator. I'm going to rewrite this right here. We've done this before. To get rid of the 7 in the denominator, we're going to multiply through distributive property across the equal sign everything times 7. So it looks like 7 times 5/7 x plus 7y equals 14. And these will cross cancel, and that leaves us with a standard form 5x plus 7y equals 14 for our final standard form answer from the original equation. If you're given a set of xy such that the equation is y equals x plus 5 and set, then this is where we make a chart for x, and we want to yield the y. How do we do that? The y equals x plus 5. We're going to go out and grab something around 0 to start filling in for x. So a -2, a -1, a 0, a 1, and a 2. We substitute it in to the middle expression we were originally given. -2 plus 5, that's a 3. -1 plus 5, that's a 4. A 0 plus 5, that is 5. A 1 plus 5 is 6. And a 2 plus 5 is 7. We now have an x term and a y term for plotted points to graph from that expression that was originally given. So our first one is -2, 3. So we're going to graph that. So we have -2 for x, 3 for y. Then we have a -1, 4, -1 for x, 4 for y. Zero for x, 5 for y. We see a pattern emerging. 1 for x, 6 for y. 2 for x, and 7 for y, way up here. And we're going to connect our graph from y equals x plus 5, originally given as our expression. So it's just substitution and you're deciding on the values that go in for x. Hovering around 0 helps quite a lot. Okay, our next one, you're asked to graph x plus 3y equals 4. Solve for y first. We will have a minus x both sides. We'll have 3y equals negative x plus 4. We will have divided by 3. We will have now y equals negative x plus 4 divided by 3. Okay, we're going to take that information and put it in chart form. Again, you're going to go out and choose some numbers to substitute in. Say we pick 1, 4, and a 0. 0 is always easy to substitute in. Everywhere we see an x in our expression for y, what y equals from what we solved for, we can plug in that number we substituted. So a 0 gets substituted in for x, negative 0, so to speak, plus 4 divided by 3. X is 0, but now y is 4/3. Alright, a negative 1 plus 4 over 3. If x is 1, then negative 1 plus 4 is a 3. 3 over 3 is a 1 for the yield on the y. A negative 4 plus 4 over 3. Negative 4 plus 4 is 0 over 3. It's 0/3. A total 0 for our y. We plugged in 4 for x, 0 for y. So this would be like an xy plotted point in our chart. So if we plug in 0 for x and 1 1/3 for y, be here, sort of. Okay, and 1, 1 for another x and y value, and 4, 0 for another x and y value, and connect those. That is graphing our expression from our chart. Okay, if you're asked to graph and whether it is a function from an expression, then, and we're determining whether it is a function from an expression, we have something like y equals negative 2 given to us in our chart. Y is always negative 2. Well, what about when you picked values for that? What if x is negative 3, 0, 4? I am just grabbing numbers around 0. I'm choosing them. What we're given, though, is y is always negative 2. So if y is always negative 2, here's our negative 2 across y. We're going to plug in some points. What about a negative 3, negative 2, this point? How about a 0, negative 2, this point, and a 4, negative 2, this point? Okay, connect those. This is a 0 slope. And to determine whether it's a function, we can do the vertical line test. So we have yes. It is a function at 0 slope, where y equals negative 2. If we were given x equals 3, and we make a chart, x and y, but x is always 3, I'm going to plug some values in for y, and around 0, negative 2, a 0, a positive 2. So x is always 3. We have 3, -2 to plot. 3, 0, and 3, 2. Connect our dots, our graph of our expression, x equals 3. Okay, this is undefined. And from the vertical line test is not a function. Okay, if you are asked to graph with y-intercepts and x-intercepts, and you're given something like 2x plus y equals 6, you want to find the x value when y is 0 and the y value when x is 0. So when we plug in 0 for y, we get 2x equals 6, and now x equals, divide by 2, 3. So our plotted point there is 3, 0. And in our expression, when x is 0, this is y equals 6. And so the y-intercept now is when x is 0, y is 6. And these are where the points land on the graph at the y-axis and the x-axis. So at 3, 0, it would be this intercept on the x. At 0, 6, be this intercept on the y. And we'd see where these cross each axis. So you plug a 0 in for the opposite x or y, whatever you need, to find the x or y value that you need. 0 for y yields an x, a 0 for x yields a y. And if you're asked to graph, you can graph those. Okay, remember to make a chart. Remember your standard form, ax plus by equals c. Remember to grab values around 0. Your function of x is equal to the yield of your y. And check out the slope videos I have up as well. I hope this helps, and I'll see you soon.